Hello, everybody. In this video, we'll talk about Condorcet candidates, what they are, um, and how they kind of add another wrinkle into a method, trying to find a method for a good, fair um, election. So, what I have up on the screen here is this example that we've been looking at from the first video and second. Um, and it concerns some kind of an election between four individuals, A, B, C, and D, or Amanda, Bob, Cameron, and David. And we used the plurality method before to determine a winner. And let's recall exactly how that worked. So the way we use the plurality method is we just count the number of first place votes that a candidate has received. And we can count that looking at the preference schedule, excuse me. So if we're looking at candidate A, Amanda, we found that there's just 3 votes. B, we found that there were 4 votes for Bob. C, and remember the 4 votes came from 3 here and 1 here. For Cameron, we had 2 and 1 votes from the various schedules, so we got 3 votes totally for Cameron, and then David had 2 votes. And when I say votes in this particular case, 2 first place votes, 3 first place votes. The other votes are really just not relevant for the plurality method. And if you'll recall, well, we can see who won if we just consider first place votes. If we're just using the plurality method, we found that Bob wins this election. And we found a few things that might give us pause with the plurality method last time. And one of them was that when we looked at Cameron, we saw that Cameron had a lot of second place votes, a few first place votes, and okay, maybe 1 third place vote. But Cameron had quite a few good showings, whereas while Bob won the most first place votes, Bob also won the most fourth place votes. So Bob was a controversial winner, let's say. So now what I want to do is I want to look and see, well, what if we just took this preference schedule and we decided to make it a head-to-head matchup between the various 2 candidates? So in other words, we choose 2 candidates and we ask who would have won if it were just the 2 candidates running. So let's take a look and see if we can figure that out. And here I'm just going to look, and I've got an inkling that Cameron would have done very well. So let's ask about Cameron. Cameron in head-to-head matchups. And okay, well, Cameron could have been versus Amanda. Cameron could have been versus Bob, or Cameron could have been versus David. And let's see what happens. Okay, so if Cameron is just versus Amanda, what happens there? Well, I will get rid of Bob and David in this particular case. We'll just get rid of them. In other words, we'll cross out their showings in the various ballots in the preference schedule. So Bob and David, Bob and David. And now we just can look and see Amanda and Cameron in this schedule. And when we do that, we can say, okay, well, how many votes does Cameron get versus how many does Amanda get? And well, if I just look at it, I've got Cameron winning here, Cameron winning here, Cameron winning there, Cameron winning there, and that's it. So the only places where Amanda wins are this preference schedule and this preference schedule. So there are 3 and 4. So Cameron gets 4, or sorry, pardon me, Amanda gets 4, and Cameron would get the remaining 8. So uh, it's 8-4 in favor of Cameron. So in that head-to-head matchup, Cameron is winning versus Amanda. Okay, what about versus Bob? And remember, Bob is the winner according to our plurality method. So let's take a look and see what happens if it's just Cameron and Bob. All right, so I'll get rid of all these crossed out. Votes, and we'll come back and cross out the ones now with. So if it's Cameron versus Bob in the head-to-head, then Amanda and David are out. So we'll just get rid of them. Amanda and David don't matter in this head-to-head matchup. Okay. Okay, so now let's take a look. Well, it looks like the Bob wins here and here. And it looks like in every single other preference ballot, Cameron's winning. So the only votes that Bob would have won in that head-to-head matchup, well, are from those schedules, so there are 4 of those. And that means that Cameron, again, is getting 8 votes versus Bob. So Cameron gets 8 versus Bob's 4. And again, we see in this case, in this head-to-head matchup, Cameron wins. All right, well, let's take a look at one last example, Cameron versus David. And you might imagine that this is going to be sort of no contest. I hope. We'll see. So Cameron versus David, both Bob and Amanda, they're not relevant to that matchup. So Bob and Amanda I'll get rid of. And then we can take a look and see, okay, Cameron versus David, does David ever win? David wins exactly twice with these 2 particular ballots, these 2 ballots. So in this case, it's really just lopsided. David wins 2, Cameron is winning 10, or 10-2. So Cameron again is winning. And this is a bit of a odd thing here, because again, plurality method says Bob wins, but one-on-one, Cameron versus anybody, Cameron's winning. So that I think illustrates pretty severely some of the limitations of plurality method. Now, in this case, when you have a single candidate that when they go head-to-head versus any other candidate, they win, we call them a Condorcet candidate. So Cameron is a Condorcet candidate because she is winning versus each of the other candidates. So I'll just say that. So I'll just say this means, this being that when we match her up to any other candidate, she wins. This means that she's a Condorcet candidate. All right. So let's take another look, another example here, just to make sure we're on top of this and seeing whether this phenomenon is just something quirky about this example I gave, or maybe it's something we'd see in other examples as well. So here I uploaded or reproduced one of the examples from the book. And this example is used a lot in the book. It's really illustrates a lot of the different features of the different methods for voting. And this is based on an example where some math club is voting in candidates, and we arrive at some preference schedule that's written here. So I want to go through and make sure, this example again, and make sure that we understand the plurality method. And then we'll see, is there a Condorcet candidate in this example? So, well, let's see. How do we apply that that plurality method again? Well, again, we're counting up the number of first place votes. And the number of first place votes for A, well, they all come from this type of preference ballot because A is not in first place in any other. So we can just count those. We see that there are 14 of those. B has a similar situation. They only have one ballot where one preference ballot where they're first place, and that's here. And so there are 4 of those. So B gets 4 first place votes. C, on the other hand, there are 2 types of preference ballots that C is first place on, and it's here. So we get 10 plus 1, 11 votes for C. And then D, only one type of preference ballot, and that's this type, and there are 8 votes there. Great. And so we can see, again, we have a clear winner according to the plurality method, and that is that A has the most first place votes, so A wins this election based on plurality. However, again, we see from the book that A has this same kind of phenomena that Bob had. A won a lot of first place votes and a lot of fourth place votes. So while A is winning from plurality, A is the most unpopular of all of them. And so uh, maybe it's not the best thing that A is winning. On the other hand, if we look and see, some of the other candidates, we might be able to find a candidate that's doing, a little better than A, let's say. So what I'm going to ask now is I'm going to ask again, can we find a Condorcet candidate for this case? And again, I'll look and see. Well, we can take a look and see about B, because B, and this is again, why am I choosing B? Well, I'm looking at the second place showing, and I see, well, B did pretty well in second place for a lot of votes here. B got first place for a few votes as well. So maybe B has a chance at being a Condorcet candidate, even though A won the election. Let's take a look. So here I need to look at the head-to-head matchups of B versus any of the other candidates. So let's do B versus A, our presumed winner, B versus C, and B versus D. Great. Well, B versus A, I'm going to cross out C and D and see what kind of results I get in that case. Okay. So when I do that, I see that, well, A wins these 14 votes. What else? Well, it looks like A loses every other. So A has 14. B has the rest of the votes, and let's do a quick count to see how many votes there are total. Total votes. Well, I've got 14 plus 10, that's 24, plus 8 is 32, plus 4 is 36, and then I have 37, one more vote. So I have a total of 37 votes, and 37 minus 14 is 23. So B had 23 votes to A's 14 in the head-to-head matchup, if we were just to eliminate the remaining candidates. So here, B wins in that head-to-head matchup. Okay, what about if we do the head-to-head matchup of B versus C? All right, for that, we need to eliminate A and D. We will do that. We'll get rid of A and D. And we'll see which one's B is winning. All right, so it looks like B wins which ones? So, well, B wins here, B wins here, but B is not winning anywhere else. So B wins 18, 14 plus 4, 18 of these head-to-head matchups. So B wins 18. And C wins 37 minus 18, which, as everyone can count, hopefully is 19. So actually, B loses here, and my guess did not prove out. So in fact, here we see C wins. So certainly what we can see here is that B is not a Condorcet candidate because it's not winning in the head-to-head matchup with C. So therefore, I'm not going to even consider B versus D because, well, for now, B is off my list. It looks like C is winning versus B, so I'm going to start looking at the other examples of C versus B. So let's take a look. My guess was not quite right. Let's take a look and see if we can see what happens when C does head-to-head matchups. So here I'll go A versus C, and I'll go D versus C. So if I'm doing the head-to-head matchup of A versus C, that means that B and D are out. So let me get rid of B and D. Let's see, do I have a Condorcet candidate here? Let's take a look. All right, I'm A versus C. A wins there, but A loses everywhere else. So A again gets 14 votes. Oops. And C gets the remaining 23 votes. So in this case, C is the winner of that head-to-head matchup. So let's take a look at D versus E. Right now, we don't know for sure if we have a Condorcet candidate with C. We need to check this last matchup. So let's do that. And if it's D versus C, then A and B are not relevant. So I'll get rid of A and B. And now let's count votes here. Okay, so where is C winning? C is winning here, here, not there, not there, and not there. Okay, so the last three, oops, pardon me, C wins here, here, and actually that last one. So C is doing pretty well there. So we have 14 plus 10, that's 24, plus 1 is 25. So C wins 25 votes, D wins the remaining 12 votes. And so it's clear here that C is winning. Great. So we see in the head-to-head matchups, my first guess that B might be the Condorcet candidate was not right. However, we will find out when we do those head-to-head matchups and get to the place where maybe we find the Condorcet candidate. In this case, we did. C is, I'll just say C is Condorcet candidate. And again, one would think that if you have a candidate that's winning every head-to-head matchup, if they're the Condorcet candidate, that they should win the election. They can beat every other individual in the election. So this again shows some of the limitations of the plurality method. Now, from this discussion, these two examples, one might think, okay, well, why don't we just throw away the plurality method and just use this head-to-head matchups and see if we can find a Condorcet candidate. If the Condorcet candidate's there, we'll just find that person, and that person's the winner. And the reason that that is may be an issue is illustrated in this example. So let's take a look. And this example is just one that I cooked up. So let's see what happens here. So first, let's look at the plurality method and count the first place votes. So here it's quite easy because each candidate has only one preference ballot in which they are the first place candidate. So we can see that we have 32 votes for A, 33 for B, first place votes, pardon me, and 35 first place votes for C. So here, by plurality method, C wins. They have the most first place votes. But as we've just seen, right, that's not enough, at least to be a convincing win. So we should do head-to-head matchups and see what we can get. Now, when you only have three candidates, there are actually only three ways to get a head-to-head matchup. Namely, just remove one of the candidates and you'll get a head-to-head matchup. So you have three possible head-to-head matchups here. We have A versus B. That's removing C. We have A versus C. That's removing B. And we have B versus C, removing A. So let's see what happens. So A versus B, we just have to forget about C. So we'll get rid of C. And we can see now in this matchup that A receives first place votes for all of these ballots and for all of these ballots. So that's 67, 32 plus 35. And B receives the 33 votes that are the first place votes. So in this case, A is winning this head-to-head matchup. A wins. Okay, what about the matchup A versus C? Well, in this matchup, oops, we are going to get rid of B. So let's get rid of B. And we can see that in this matchup, A is still receiving its 32 votes, but all of the remaining votes, 33 plus 35, go C's way. So, sorry, this is 2. So here we have 68 votes going to C. So in this case, this head-to-head matchup, C wins. And then finally, in the head-to-head matchup B versus C, we have to get rid of the A votes, all of the votes for A. So let's get rid of A. And we can see here, B is winning these ballots and losing the remaining ballots. So B receives 65 votes to C's 35 votes. So in this case, B wins the head-to-head matchup. And if we were to try to do what we were doing a moment ago, which is saying scrap plurality, and we will just go with the Condorcet candidate, we would be in a kind of a bit of a bind here, because there is no Condorcet candidate in this case. If we look at head-to-head matchups, no one candidate wins each head-to-head matchup with the other candidates. So in other words, if we're looking at A versus B or C, well, sure, A wins versus B, but not versus C. If we were looking at C versus A and B, well, C wins versus A, but C does not win versus B. And then finally, if we look at B versus all the other candidates, B versus A wins, so B is not winning versus all the other candidates. So no Condorcet candidate in this case, and sadly, we have to do a little more studying to see if we can find a better voting method that will always give us a candidate that we believe in.